Let's look at problem 26 on page 302. Number 26. Data on the height of American adult males came from results of physical examinations reported to the National Center for Health Statistics in the period from 1976 to 1980. From these data, the mean height of American males equals 69.1 inches. In a sample of 50 male college seniors, we find a mean height of 71 inches and a standard deviation of 2.1 inches. These data give t equals to 6.40 on 49 degrees of freedom, and it says the p-value is less than 0.0001. Alright, by the way, 49 degrees of freedom means there were 50 people in the sample, which of course is what the book tells you. Alright, part A, what is the null hypothesis for the data on the college seniors if we want to find out if the college students are different from the general population? Okay, well, the null hypothesis is that the mu is equal to 69.1. In other words, college male seniors, and just, excuse me, I want to make sure that's, all right, good. I have my new camera here. I want to make sure I have it focused right on the board and picking up everything. Null hypothesis is that the college male seniors are same height as American men. Okay, abbreviated a little bit there. Same height as American men. Alright, so what's the null hypothesis if we want to find out if college students are different from the general population? Well, then, what is the alternative hypothesis? The alternative would be that mu is greater than 69.1. And I need to erase my numbers here. Didn't place them very well. And of course this means that the college male seniors are taller than the average American man. Alright, so now we're not trying to prove that mu is equal to 71.0. That came from the sample. There, that was X bar, was 71.0. They took a sample of 50 men, not 49, got that wrong, 50 men. And they had a standard deviation of, what was that, 2.1. So this came from the National Study for Health Statistics number, and we're comparing, using the sample, we're comparing that to the status quo. And so that's how you would set up that hypothesis test. Now, part B asks, what can we say about the mean height in the population from which the sample came? Do we reject or not reject the null hypothesis? Well, we would reject, wouldn't we? Because the p-value is less than 0.0001, then we reject the null hypothesis. Again, let me explain what that means to reject a null hypothesis with this p-value. It says that by rejecting this null hypothesis in favor of the alternative, I'm claiming that American college men are taller than the average American man, based upon this evidence. And the probability that I'm making a mistake in rejecting the null hypothesis, that probability is less than 1 in 10,000. Tens, hundreds, thousands, 10,000s. So, you know, the odds are very low that I'm making a mistake with this. In other words, what's the probability of getting a sample of 50 college male seniors drawn at random and finding out that the average of that group is 71? What's the average of that? What's the probability of that happening if there really are no different from the rest of the population in general? Well, the odds are extremely low. So that's enough to say, this is very significant. We reject the null hypothesis in favor of the alternative. So that's pretty much that problem. Okay, let's go find another one.